Good luck. Okay, let me turn this light off. First off, Chapter 11, like I said, it's quick. Mathematics, it's the easiest chapter of the year. So, Emily, you'll like this one. There is 0 math in Chapter 11. There is some math in Chapter 13. The test for Chapter 11 and 13, it has 1 mathematical free response. That if we just, Chapter 10, did some like 6 or 7 difficulty questions, like level, these are at a 2 or a 1. Okay? They're significantly easier. That's 13. And then the other multiple choice is like Chapter 7 multiple choice, where you may remember I gave you something that was true and you explained why. Like it'll say the boiling point of this is 2,000 degrees. This one is 100 and this is negative. Why? And you have to explain why the 3 things have such drastic melting or boiling points. Okay? So there's one that's 100% explanation and one that's all math, and then there's 10 multiple choice questions that we will go over most of them. Now, that worked really well for Chapter 8 and 9. For Chapter 10, we went over 7 out of the 10, and we didn't do very well. Still on some of those I gave you. Like one of them we did twice, and still it didn't score well. So make sure if it's cut out, it's a little white box down here, it's going to be a question on your test. If it's typed out and it looks nicely written, it's probably one cut from your test, because I don't do things nice. Okay, homework-wise. You have to do the Ed puzzle to get points. The Khan Academy videos are 100% recommended, but I will not grade them. All right? But there's 3 or 4 Khan Academy videos that will do this entire chapter in about an hour of total watching. Included in those are 2 AP test questions that they explain the answers to. All right? They are linked in Canvas or behsscience.com. All right. Now, this is the only chapter of the year that I think I make you learn vocabulary terms. I saw that look, Olivia. This will be nothing like MedTerm. All right? But there are a lot of them. Now, my advice is to take a picture of this screen. You can write everything down, but I'm not going to leave it up here for 10 minutes. All right? Quite a few of these are on that handout I just gave to you. All of them are in Chapter 11. And all of them will be tested in a matching format. Okay? Now, that's rough. It's the only time in my entire career I do a matching that goes A through T. That's T for terrible. I mean, usually the matching terms are like 5 of them, right? So, I'll pause it, and I don't know. I haven't decided how I want to teach this chapter. But we're going to go over the reader together. That's what we're going to start with. All right? So here we go. This is like church. When you're like, why are you reading something to me I can just read to myself? Because it's America. I'm going to do what I want to do. All right. This chapter deals with intermolecular forces in liquids, solids, and gases. The majority of time will be spent on liquids. So really, Chapter 11 is the properties of liquids. All right? Now, you need to know what an intramolecular force is versus an intermolecular forces. All right? Intramolecular forces are the attractive forces within molecules. These forces are generally referred to as covalent bonds. These forces give molecules their chemical properties. So if we have water, which is HOH, we are going to define the bond between O and H right here as an intramolecular force. It's the covalent bond where oxygen needs 2 electrons, 2 hydrogens have 1 each, they share, and they hook up together. That's an intramolecular force. All right? Intermolecular force. All right? If we had water, and we know water's polar, right? We'll talk more about that, but we should know that by now. That makes this N slightly negative and this one slightly positive. All right? if I had another water molecule, that was not good. I need to go this way. All right, hold on. I made a shortcut with my new slate. I just got to get used to it. There we go. If I made another one of these, oh, I needed to clone. Sorry. The infinite cloner will work. Okay. No, drag. All right. Then I would say the intermolecular force would be the attraction between the H's and the O's. And I know that sounds the same, but I said the word attraction now instead of the word bond. Okay? The attraction due to the properties of the molecule attracting to each other, that's an intermolecular force. Okay? Drawing this picture and like pointing arrows and defining them definitely can help you to understand the difference. All right. So, in our high school, oftentimes the internet goes down. We've heard of the word internet, right? But when the internet goes down, like the internet, when the internet goes down, I can still email anyone in this school. Do you know why? Because the intranet is still working. The computers inside this school can still talk to each other even if the World Wide Web isn't working. Okay? So there's inter and intra in more than one place. There's interstate, intrastate. That one they don't really define the difference there. So I don't know. It works, but it's not as good. All right, here we go. This is huge right here. The physical state of a substance depends on the balance of the kinetic energy. And definitely remember, kinetic energy means temperature. So that's why I can change the state of the substance by heating it up or cooling it down. Okay? But the state depends on the balance of temperature and the attractive forces between the molecules themselves. All right? Remember when we had a gas and I said, hey, if we pressurize it, we're going to get them closer together and the gas might behave more like a liquid? Okay? But then we had temperature involved in that as well. We're all talking about this thing and whether it's going to be a gas because the things aren't attracted at all, a liquid because they're sort of attracted to each other, or a solid because they are really attracted to each other. Okay? All right? This is why the state of the substance can be determined by knowing its temperature. These forces determine the boiling point and the melting point of a substance, and this is what we care about the most in this chapter. In general, answer this in a short discussion with your partner and then write it down. All right? In general, as the intermolecular forces increase, so this one, the melting and boiling point also increase. Why? I would like you to literally discuss, and then after you've discussed for a solid minute or two, write your answers to why right there. Now, listen, a hydrogen bond is not just a magnet, but it's close enough for our model. Are you okay with that? So if you have one single water particle, and you don't need to do this part, and I don't even know if I can because I'm not, oh, there we go. If you have a water molecule, the whites are attached to the red, correct? All right, you do not need to pry it apart, and please don't. This would be an OH, right? And an OH would be, it has to be a minus, correct? So OH needs an electron, so it gets it from that hydrogen. So the hydrogen comes and shares an electron, and it does it twice to make water. This bond is a intramolecular bond or force, the attraction between the O and the H in the covalent bond. Now, it's right in front of me. If you take a second So when we talk about intermolecular forces, you have to have at least more than one atom or molecule. Well, atom's fine too. You have to have at least two independent things that will then interact with each other. And that magnetic force is my intermolecular force. And the stronger that magnetic force is, the harder I have to pull on it, right? If these were really strong magnets, it would take more pull. Now, we're not pulling on it, but we would be heating it. It would take more vibrational energy, because that's all we're doing. No one's even looking at me. That's fine. I don't care. But when we heat, we're going to make the thing vibrate. And when we get to a certain point, it will separate because we put enough energy in. The stronger the adhesion, all right, or the attractive force, the harder it is to pull them apart. Are we okay with that? All right. You are welcome to play with your water, but we need it all back in that bucket eventually. Oh, the gray, which I didn't pass out, but this represents methane, CH4. Now methane, right here. Methane is a nonpolar substance, which means it does not create any type of like hydrogen bond or any type of pole, a plus or a minus. So the methane is not attracted to the water in any way at all. You okay with that? Because there's no magnets in this one. All right? But methane has a really, really, really low melting and boiling point. Because there's very little, there's always some, we'll learn. But the attraction of one to another is almost zero compared to this, and that would be like 1,000 or something like that. Okay, we all right with that idea? Yeah, once we get to 212, we can completely separate all water molecules from every other water molecule. We can make water sort of boil lower than 212, just not all of it. And that's what vapor pressure was. All right? Vapor pressure is when there is enough energy to make some of them leave the liquid environment. All right? But not all of them. Boiling is when all of them do. All right. I'm sure that was fascinating if they're just watching the video here. All right. There are 3.5 or 4, whatever. Someone spilled some water. Ha 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 ha. Let's get a mop. All right. No, it doesn't work well. They're not that strong. Okay. This is the MIP of this whole chapter. What do you think that is? Part, principle, whatever you want to call it. This is all of them. Everything on this slide is important. So there are 3 types of intermolecular forces. You have to know, understand, and determine the type it has in it. So first we have what we call ion dipole forces. Now, I guess I should explain what a dipole is. It was in a previous chapter, but raise your hands if you remember what a dipole is. 1, 2, 3, 4, 5, 6, 7, 8. I think most of those people that raise their hands probably have read the book. A dipole exists. We just drew water. A dipole exists when an electron is pulled more strongly towards something. And we put these arrows on the end, right? So the dipole movement in this is the electron, the negativeness, whatever you want to say, would be negative up here and positive up here. In order to have a dipole that matters much, we have to have a polar. So that's the dipole. Di means 2, pole means sides, a negative side and a positive side. So here we go. An ion dipole force is exactly what it sounds like. It is an attraction between an ion and a polar molecule. A common example is salt in water. And you know what? you're going to have to explain a saltwater solution exactly on your test. The polar water molecules are attracted to the sodium and chloride ions. Okay?